Welcome back to part 2 of the AP Computer Science Principles multiple choice practice. So let's go ahead and jump into this first one. This first one says, the program segment below is intended to move a robot in a grid to a gray square. The program segment uses the procedure GoalReached, which evaluates to true if the robot is in the gray square and evaluates to false otherwise. The robot in each grid is represented as a triangle and is initially facing left. The robot can move into a white or gray square, but cannot move into a black region. We have this procedure here, so we keep repeating it until the goal is reached, so until it reaches the gray square. If we can move forward, we're going to move the robot forward. Then if we can move right, we're going to rotate right. And then if we can move left, we're going to rotate left. And then if we can't do any of those things, we're going to go back up here as long as our goal is not reached and go through that procedure again. So I think it kind of helps if you write it out like move forward if can, rotate right if can move right, and then rotate left if can move left. So you can kind of see the steps that we take here. So if, for example, we're somewhere where we can't move forward, then we need to check if we can move right and then rotate right. And then if we can't do that either, we're going to rotate left if we can move left. If we can't do any of those things, we're going to go back up to the top and try to move forward again. All right, so with this problem, it says, for which of the following grids does the program not correctly move the robot to the gray square? And then we're given 4 grids. So let's go ahead and just take them step by step, see which one will not move it to the gray square. So this first one is pointing to the left. Can we move forward? Yes, we can. We can move into this block here. So we're going to go ahead and move forward. Then we try to move right. We can't move right because there is these dark gray squares, or I guess they're calling them black regions. There's these black region here that we cannot move right to. So we can't move right. And we also cannot move left because left there aren't any white or gray squares to move into. So we go back up to the top to step 1 and we try to move forward, and we can. Awesome. Then we see if we can move right and rotate right if we can. It looks like we can, so we're actually going to rotate our robot, so now it's facing this way. Let me erase this. So now we are rotating our robot and it's facing north. So then we try to see if we can move left to rotate left. There's no square out here for us to move into, so we cannot rotate left. So we go ahead and we see if we can move forward. Yes, we can. We see if we can move right. No, we cannot. Move left. No, we cannot. We move forward again because we can. We do that same check. Can we move right? Can we move left? No, we cannot. So we move forward. I'm just going to speed it up a little bit just because I hope you're sort of starting to get the idea behind this procedure. So then, once again, we can't move right, we can't move left, so we move forward. Now we need to check if we can move right. Yes, we can. So we're going to go ahead and move our little robot such that it's facing east, north, east, south, west. So we can't move left. There's no square to the left of us. So we're going to go back up. We're going to move forward because we can't move right and we can't move left. So we're going to once again try to move forward. And look at that. We've made it into our gray square, which means that we've reached our goal, which means that we're done with this procedure. So it looks like A is not one of the grids for which the program does not correctly move the robot to the gray square. So let's go ahead and move on to the next grid. So we're starting facing the same way, we're facing west. Once again, we're going to move forward because we can't move right or left. We're going to move forward again after that. Now we can move right, so we're going to rotate ourselves so we're facing north. Then we can't move left, so we're going to go forward. We can't move right, we can't move left, so we're going to move forward again. Now we can move to the right, so we're actually going to rotate to the right. And then we can't move left, so we're going to go back up to step 1. We're going to move forward. Can't move right, can't move left, we step forward. Now we try to see if we can move to the right. We can't, there is a black square there, so we rotate to the left because we can move left. And now we're facing north again. We move forward because we can, so now we're in this square. We can't move right, can't move left, so we need to move forward again. And then this time we can't move right, but we can move left. So we're going to rotate to face this way. So then we move forward again. Okay, we can't move right, we can't move left, so we move forward again, and we have made it to the gray square. So it looks like B is not a grid, for which we will not make it to the gray square. All right, moving down to C, still facing west to start off, so we move forward to begin. Can't move right, can't move left, we move forward again. Now we can move right, so we're going to rotate right. Now we're facing north. We can't move left, so we're going to move forward, which we can do. Can't move right, can't move left, move back up to forward. Now we can move right, so we're going to rotate ourselves to be facing to the right. Can't move left, so we're going to move forward. Now we can't move right, but we can move left, so we're going to rotate such that we're facing north. We move forward again. And then we can't move right, can't move left. We move forward again. So now we can move to the right. So we're going to rotate right. So we're facing east now. Then we can't move left. So we're going to move forward. And it looks like we have made it to the gray square again. So it looks like C is not the correct answer as well. So just by process of elimination, you can kind of see that D is going to be the right answer. But let's go ahead and see why it is going to be the right answer. So we're facing west to start off with. We move forward because we can. Can't move right, can't move left, we move forward again. This time we can move right, so we're going to rotate right. So now we're facing north. We can't move left, so we're going to move forward again. Can't move right, can't move left, we're going to move forward. Now we can move to the right, so we're going to rotate right. Can't move left, so we're going to move forward. Can't move right, we can move left, so we're going to rotate to the left. So now we're facing north again. We move forward again. We can't move right, we can't move left, we move forward again. So now we can move right. So what we're going to do is we're going to rotate ourselves to the right. So now we're facing east, and then we can move forward. And so, all right, so now when we try to move right or move left, we can't do either one of those things. So we're not going to be rotating at all. We make it back up to our move forward step. We can't move forward either. There's no square in front of us. So we're actually stuck in this corner and we will never reach the goal, which is that gray square. So D is the correct answer here. Moving on to the next problem, we see this one says, biologists often attach tracking collars to wild animals. For each animal, the following geolocation data is collected at frequent intervals. So the first one is time, second one is date, third is location of the animal. So this question is asking, which of the following questions about a particular animal could not be answered using only the data collected from the tracking collars? So then we're given 4 questions, but we need to figure out which one we couldn't answer with just the time, the date, and location of an animal. So first one says, approximately how many miles did the animal travel in 1 week? So we're asked how many miles, and they traveled in 1 week. So I would say we can answer this with the tracking collars. So we're given the location of the animal. So that means that if we had like some sort of map, and like the animal was over here one day, and then it was over here another day, and like, you know, we can pinpoint the distance between those locations to figure out how many miles they traveled in 1 week. And also the 1 week part of this answer we can use using the time and the date, right? So we have that location data, and we also have like maybe on Monday they were here, maybe on Tuesday they were here, you know. So we have that information. So I would say that A is one that we can answer using just the data collected from the tracking collars. B says, does the animal travel in groups with the other tracked animals? I would say that you could also answer this using the data collected from the tracked collars. So this is not the right answer as well. The reason being is, so at the start of the problem, it says they attach tracked collars to wild animals, and we're asked about the other tracked animals. So let's say, for example, like one of the animals is here, and then another one of the animals is really close nearby, and another one is near as well. So we can see, since we have the location and time data for each of these animals that we're tracking, we can tell if they're moving together because we have that information. We have, once again, like let's say on Monday at like 3 p.m. they were all here in this location. And then let's say Tuesday at like 4 p.m. our location data shows that they moved over here. So we would actually be able to figure out this with the data collected from the tracking collars. So C says, does the movement patterns of the animal vary according to weather? So weather. All right, well, time, date, and location of the animal, I wouldn't say any of those have to do with weather. We We definitely need additional information here to know if it's varying according to the weather. Using just the time, date, and location of the animal, we cannot accurately say if, they moved over here because there were rain clouds over here without some sort of other information about the location's weather. So I would say C is the correct answer. Let's go ahead and see why D is also can be answered using just the data from the tracking collars. And what geographic locations does the animal typically travel? So this one also we should be able to answer with the location of the animal. Yeah, that should just make sense. The correct answer here is C. All right, so this is the final problem, and this one says consider the following program code. And we set I equal to 0, we set some variable equals 0, we repeat that until I equals 4, so you can kind of think of that as like a while loop. While I is not equal 4, we're going to do the code inside of here, which is setting I equal to 1, setting the sum equal to sum plus I, and then I equal to I plus 1. And then as soon as we're done with that while loop, we will display sum. And this problem asks us which of the following best describes the result of running the program code. So I went ahead and I copied it down by hand, just so I think it's a little bit clearer seeing it like this. So let's go ahead and try to run it and see what happens. Initially we set I equal to 0 and sum equal to 0. Cool. Then while I does not equal 4, so it doesn't, right? 0 does not equal 4. We're going to set I equal to 1. So I is now 1. Then we set sum equal to sum plus I, so 0 plus 1. So our sum is 1 right now. Then what we do is we set our I equal to I plus 1. So 1 plus 1. So we set it equal to 2. Okay. All right, so we're getting a little bit closer to 4, but we still have not made it equal to 4, so we have to keep looping. So what ends up happening here is we set our I back to 1. We set our sum equal to sum plus I, so 1 plus 1, so now it's equal to 2. And then we set our I equal to I plus 1, so 1 plus 1. So now we have our I is 2. Okay, wait. Something's amiss here. We just had I equal to 2 in the previous iteration of the loop, and now it's once again, we went through the whole loop and it's 2 again. Well, you might notice that every single time inside the for loop, we set our I equal to 1. And then at the end of the logic, we set it equal to I plus 1. So that's going to be 2. So for all the progress, quote unquote, that we make within the loop to increment our I, it's always just going to go back to 1 and then increment to 2. And then once you go into another iteration of the loop, it's going to go back to 1. So we're actually not making forward progress within this loop. So I would say the correct answer for this is nothing is displayed. The program results in an infinite loop. At no point are we actually going to reach the 4 that we need to stop the loop. So I would say nothing is displayed here. The other 3 answers are incorrect because, to reach this part of the code, we need to actually reach I equals 4. We are never going to do that. So the correct answer is D here. Hopefully that helps you out with these AP Computer Science Principles multiple choice questions. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.